Dear students, in this lecture we will study about the Gauss Seidel method to solve system of linear equations. In the previous lecture we have learned that how an iterative technique is used to solve the system of linear equations, and Jacobi's method was studied there. And now in this lecture Gauss Seidel method will be used to solve the system of linear equations. There is a bit difference between Jacobi and Gauss Seidel method, so try to note that step. What is the main difference between these two? So let me explain in front of you. The first thing is you need to write the system in diagonally dominant form. That is very important step. You need to write the system in diagonally dominant form, and secondly you need to write the diagonally dominant form in iterative form. And the third one is initial guess will be given to you to perform the different iterations, but in this sense we need to use the most updated values of xi's. That is the difference between Jacobi and Gauss Seidel method, that in Gauss Seidel method we will use the most updated values of xi's and so on, and continue the process until the required accuracy is achieved. What is the required accuracy? If the two consecutive values of xi's are nearly equal to each other up to a desired decimal places, then that will be the required root, or we will be asked to perform some iterations, 4 iterations, 5 iterations, to find the solution of the system of equations. So the same example will be taken here, and in this example we are asked to solve the system by Gauss Seidel method with the initial guess 0 0 0, and the system is given to us, which is in front of you. This system we are asked to perform 4 iterations. So in this question we should perform 4 iterations by using Gauss Seidel technique. As the system is not diagonally dominant, because the coefficient of x1 is not greater than the sum of these two coefficients. Similarly, in the second equation, the coefficient of x2 is not greater than the sum of the rest of the coefficients. And similarly, in the third equation, the coefficient of x1 is 1 here. So we need to write the system in diagonally dominant form. This is the equation in which the coefficient of x1 is greater than the sum of all the rest of the coefficients. So we write this equation as the first equation. The second equation is okay because the coefficient of x2 1 is greater than the sum of these two, and the third equation is the third equation is 0.1 into x2 plus x3, because the coefficient of x3, which is 1, this is greater than 0.1. So now this system is in diagonally dominant form. Now we will write the system in iterative form. What does it mean? Leave this diagonal on left hand side and convert all those elements, those terms, towards right hand side. So this is equation number 1, shifting this thing towards that side, so we'll get x1 is equal to this thing, equation 1, and shifting these two on right hand side to get x2 is equal to this equation number 2, and similarly x3 will be on this side and shift this term towards that side to get equation number 3. So these are this is the iterative form of these equations. Now watch carefully. We need to perform the first iteration. The first iteration we need to use these values 0 0 0, compare it with the x1 x2 x3 to get x1 is 0, x2 is 0, x3 is 0, and put it in equation number 1. So whenever we put in equation number 1, for equation number 1 we need just x2, so x2 is 0, so put here x2 is 0 in this equation to get the new value of x1, which is 1. This is the updated value of x1. Now in the coming steps, whenever x1 arises there, we need to use x1 1, not x1 equal to 0. Remember that this is the main difference between Jacobi's and Gauss Seidel method. The new updated values will be used. We see that the new value of x1 is 1, and x3, we didn't find x3 in the previous stage. x3 is 0. So these are the updated values. So use because in this equation number 2 there are x1 and x3, so we need to use updated values of x1 and x3. The updated value of x1 is 1 and the updated value of x3 is the same, 0. So use these two to get x2 is equal to 1.9. Now this is the updated value of x2, 1.9, the new value of x2. If you see equation number 3, in equation number 3 x2 will be used here. So the most updated value of x2 will be used here. So new value of x1 is 1 and the new value of x2 is 1.9. We need to put x2 is equal to 1.9 in equation number 3 to get the updated value of x3 as 2.91. So that is the first iteration. The second iteration, the new values of x1, x2, x3 are these. So in equation number 1, on the right hand side, just x2 is needed. So use the updated value of x2, which is 1.9, in equation number 1 to get the value of x1 as 0.81. This is the new value of x1, the most updated value of x1. So whenever x1 arises there, we will use the updated value of x1 as 0.81. So put x1 is equal to 0.81 and x3 is equal to 2.91 in equation number 2 to get the updated value of x2 as 1.628. Now this is the updated value of x2. Put this updated value of x2 in equation number 3 to get the updated value of x3 as 2.8372. So that is the second iteration. And in the third iteration, we need to use the updated values of x1. x1 is 0.81, x2 is this is the updated value, and this is the updated value of x3. Now put x2 1.628 in equation number 1 to get the updated value of x1, and put x1 is equal to 0.8372, the updated value of x1, and the value of x3 2.8372 in equation number 2 to get the updated value of x2 as 1.63256, and put this updated value of x2 in equation number 3 to get the updated value of x3 as 2.836744. So that is the third iteration. And in the fourth iteration, we need to use the updated values of x1, x2, x3. So in equation number 1, only x2 is used, so use this updated value of x2 in equation number 1 to get the updated value of x1 as this thing. And in equation number 2, x1 and x3 are used, and the updated value of x1 is the previous this value, and the value of x3 is this one. So use these two values to get in equation number 2 to get the updated values of x2. So this is the updated value of x2. Put this value, updated value of x2, in equation number 3. Actually this is 3. In equation number 3 to get the updated value of x3 is this one. So we have completed the 4 iterations, and after 4 iterations the updated values of x1 is that, x2 is that, and x3 is that. So this is the required solution for the system of equations.